Yeah, I don't want to take any more time. So welcome to Zak. Zak is joining us again for our second session from the FVM team. So yeah, Zak, I'd love to hand straight over to you to kick your session off.
Awesome. Yeah, thanks. Let me go ahead and share my screen. All right. It looks like we've got a good view of that, right? Everything good? Awesome. Yeah, I'm sure Jenks did a great job introducing a lot of these topics that I'm going to go through. So I'm going to try to get through the beginning parts fast. I'm still going to do a little bit of an introduction on FVM specifically and dive a little bit into that. And we're going to kind of bring it around to the topic of DataDAOs. What are they? Go through an example, and I'll show you some code that you can get your hands dirty with. Right. So if you're not familiar with me, my name is Zak Ayesh. I'm a developer advocate with the FVM team at Protocol Labs. And yeah, I'm a huge fan of Web3 projects. I love infrastructure, so that's kind of why I'm in this space. And I'm really excited about all of the possibilities that the Filecoin virtual machine can bring to the Filecoin blockchain. So if you're not familiar with the Filecoin master plan, step one, build the world's largest decentralized storage network. That's checked off. Step two, onboard and safeguard humanity's data. This is kind of an ongoing thing until every bit of data in the world is in Filecoin. This doesn't get a check, so I think this will be kind of a target, an ideal target to reach. And step three is bring compute to the data that's stored with the storage providers on Filecoin to enable web scale apps. This is where the Filecoin virtual machine comes in, and we'll kind of talk about where that's working, and also back allow and compute over data and all these solutions that are allowing us to run useful computation over the data. Right. So what is the Filecoin virtual machine, or the FVM? It delivers on-chain programmability to the Filecoin network. We'll kind of talk about what that means, but essentially that means we're running code over the state of the Filecoin blockchain, right? And importantly, and I'll repeat this several times, this is not running computation over the data, large data sets being stored with storage providers. That's more of compute over data solutions. Right. So what is the architecture of the Filecoin virtual machine? If you're not familiar, so basically all storage providers in the Filecoin network also run a Filecoin blockchain node, right? One of the biggest nodes is the Lotus node. This is known as the blockchain client. And within that node, the Filecoin virtual machine lives, right? The Filecoin virtual machine itself is based in WebAssembly or WASM time, right? But it was designed in a way that other runtimes could be virtualized on top of it, right? So we have the Filecoin virtual machine, and on top of that, we can virtualize other virtual machines. So the first virtual machine that has been kind of built on top of the FVM is the FEVM, or the Filecoin Ethereum virtual machine, right? So we're just virtualizing the EVM within the FVM, as confusing as that sounds. And that allows users to, Web3 developers, to code in familiar languages like Solidity, that compile down to EVM bytecode, and make use of all the wonderful tools available in the EVM ecosystem, right? On the right, you'll see some upcoming projects for the FVM. Renew as a service is actually already kind of live. It's like in a beta form with Lighthouse.Storage, and we'll talk a little bit about that in a bit. Interplanetary consistent subnets is like a scaling plan for the FVM. Native user defined WASM actors are in the pipeline in the future, right? So right now you can write code in Solidity or Viper or any language that compiles to EVM bytecode and deploy that to the Filecoin blockchain. But of course, underneath the hood again, everything is kind of being transpiled to WASM. And so, it'd be awesome if developers could program in whatever language they want. And then as long as those languages compile to WASM and deploy that code in. So that's being worked on as well. And maybe a lot farther out in the future, we have new foreign blockchain runtimes. So if there's any other big blockchain runtimes that are picking up steam, they can be adopted and virtualized within the FVM, and even some non-blockchain runtimes. Right. So again, so we're all kind of understanding the stack. I think Jenks kind of covered this a little bit, but IPFS and Filecoin, two separate networks, right? Important to understand, right? They're two separate networks. They share a lot of the same components, some of the same architecture, but IPFS is more for hot data storage, and Filecoin for permanent long-term storage, right? So you have the IPFS network and the separate network Filecoin, and within that, you kind of have a layer 0. You can think of it as the storage layer, those storage providers running the Lotus nodes, right? And you can kind of think of FVM as a layer 1. It can be a little bit confusing because remember, the FVM is within those nodes. So it's not like kind of separate from those nodes, but it is like within those nodes, kind of a layer on top. And then, you can kind of think of layer 2s as storage layer dApps and solutions. And there can also be like kind of traditional layer 2s that if you're in the Web3 space, you may be familiar with, blockchains that hook into the Filecoin virtual machines. Right. So we got increasing layers. Right. So you have, IPFS for hot storage is its own network. There's a bunch of different ways you can run it. A client can run their own nodes. They can share nodes with the community, or they can use a pinning service to keep their data up. But either way, there's no kind of guarantee that your data will be stored. Meanwhile, with Filecoin, due to crypto economic guarantees, you'll have some strong guarantees that your data will be stored, right? So on the bottom here, you have the storage provider network. You can think of this as all the storage providers running the nodes, and they're kind of keeping this Filecoin blockchain alive. This Filecoin blockchain is living in each of those nodes. Off-chain files can be transferred, data can be transferred to these storage providers, right? But on-chain, on the Filecoin blockchain, is where lives what's called storage deals, and that's keeping these this data that's living off-chain, giving it assurances that it is actually there and it is actually off-chain and being stored, right? And inside that Filecoin blockchain, on every block, we have the Filecoin virtual machine, and it's running compute over any kind of transactions that are being sent in, right? And enabling these more complex dApps to be built, such as DataDAOs, which we'll cover later, and some other things that have been mentioned, like perpetual storage, right? Oh, and this is a repeat slide, so we'll fly through that. And one of the reasons, again, that the EVM was one of the first runtimes to be made available on the Filecoin blockchain is because of how ubiquitous it is currently in the Web3 space. So many developers already know and understand Solidity. And so this allows developers already familiar in the Web3 space to easily come in, port all of their code in, and use all of their favorite tools, such as Hardhat, which is a local development environment, Remix, popular online IDE for testing out dApps, Foundry, another local kind of SDK, like Hardhat, and the myriad of other tools, MetaMask, and everything you may be familiar with in the Ethereum ecosystem. So why should you use the FVM, right? We've kind of been talking about the architecture and what it can give you, but why would you use the FVM over, say, like any other EVM compatible chain, right? And the answer is pretty simple. It's storage deals, right? So storage deals are a native primitive available in the Filecoin blockchain and FVM that isn't available in any other EVM ecosystem, right? If you go on Ethereum, it doesn't know anything about storage deals or off-chain data stored, right? And so you can build out novel applications on the Filecoin virtual machine that you can't on any other kind of current Web3 virtual machine. So what is a storage deal? It is essentially the metadata of the data being stored with the storage provider, right? And it's what keeps them accountable, storage providers accountable to keeping your data stored, right? So if you look here, this is on Philfox. You can see like important data like the deal ID that particularly labels that deal, what time it was created, client ID, the provider ID, so you know exactly who's storing what with who, the size of the data being stored, is it verified, and if you were to click into the deal, you would actually see the PCID for that deal, which is kind of like the hash that represents all of the data being stored with that storage provider. So again, what isn't a storage deal and what isn't on the Filecoin blockchain is the actual data being stored with storage providers, right? So they have that in their hard drives. That data actually isn't within the logical blockchain, right? The storage deals are in the blockchain, which hold them accountable to keep that data stored, right? And, in a nutshell, they're held accountable. Storage providers have to put up fill as collateral and provide cryptographic proofs on chain that they have, that they're still storing your data every 24 hours. And if they don't, they risk getting slashed and losing the money they have put up on stake, which makes it kind of game theoretically not advantageous for them to not actually follow the storage deal, right? So storage deals are the contracts / metadata that represent the data being stored. Very common, confusing point, right? And so remember, Filecoin is a blockchain tailor-made for storing the internet's data first and foremost, and was created before the Filecoin virtual machine was even a feature, right? And Jenks covered some of the inbuilt actors in the presentation before this, right? And those are kind of functionalities that existed before the FVM, right? But maybe we want to use some of those functionalities of those inbuilt actors within our Solidity smart contracts, right? Well, again, Solidity and the EVM doesn't necessarily know about these inbuilt actors or storage deals. So we teamed up with we teamed up with Zondex, very capable and awesome team, to create Filecoin.sol, which are contracts that exist as like kind of an abstraction layer between Solidity world and the inbuilt actors world, right? So you can use Filecoin.sol in your Solidity code to interact with inbuilt actors, maybe get storage deal information into your smart contracts, and all kinds of useful things that you can do with the inbuilt actors. And so I'm going to briefly go over 3 ways you can store your data on Filecoin. And this will kind of tie into the DataDAO here in a second, right? But maybe you are storing very small data sets. We recommend that you go through an aggregator. NFT.storage was mentioned earlier. Another good one is Lighthouse.storage. And they'll take care of making the deals for you and pinning it on IPFS because that can be a little bit complicated and you need a certain amount of data before that deal can be made. The other option is to store large data sets. And maybe you want to do this programmatically, right? And you can do this through direct deal making and the client contract on the FVM, right? So the client contract is a contract standard that can emit events on the Filecoin blockchain that storage providers running a program called Boost can listen to and pick up the deals for, right? And finally, if you don't need programmatic storage, you can just use the traditional methods of getting data on the Filecoin blockchain, which involve, contacting a storage provider, either through a marketplace or offline, and sending them the data, making a deal, signing that deal with your private key. And that's kind of the classic way of making a deal. So yep, we have the 3 paths there. So what can FVM solve? Governance, tokenomics, endowment management, are all kind of applications that can be built in these new primitives like repair workers or new workers for new storage deals can be created. For instance, the perpetual storage example, right? Now you can write logic, have a DAO manage funds, and use those funds to renew storage deals before they expire. So what are DataDAOs? We built up the FVM, what it solves, and DataDAOs are an example application I've talked about that can be built on the FVM. What are they? A DAO stands for decentralized autonomous organizations. Just think of it as DAOs as adding governance processes to smart contracts, right? And I mean, this is a little pedantic. I kind of just added this here for fun. Data is a collection of discrete values that convey information. I have a feeling most of you know what data is. But what we mean kind of when we're saying data DAOs is DAOs storing data on Filecoin, right? And data DAOs are kind of used differently throughout the Web3 sphere, but when I'm referring to this and when you hear it referred to a lot from the Protocol Labs team, this is what we're talking about, right? So DAOs kind of programming and governing data being stored on Filecoin. So let's go over an example what a data DAO might look like. This is a fun example made by my colleague Sarah, and that I'm actually working on programming an example of this DAO, as we speak. But let's say like there's a Biscuit data DAO. Biscuit data DAO, if you don't know, Biscuit is the corgi mascot of the Filecoin blockchain. And Biscuit data DAO could be a community of corgi dog owners that want to better understand their corgis, right? Like a bunch of enthusiastic dog owners. And trust me, I know a lot of dog owners are very enthusiastic about their dogs. They could come in, maybe ZK verify some kind of contribution credentials, that they own their dog, or take some pictures, or whatever, somehow get verified on this DAO, and upload some corgi behaviors, data that they have into the Filecoin storage providers via storage contract. And as they upload this data, they get tokens. It could be Phil, it could be a native token native to the DAO, like some kind of Biscuit DAO token. And as they get more tokens, they can participate in DAO voting, use those tokens to vote on the DAO, and they could vote on what to do with all the data that they're collecting, whether they want to train AI and say Bacalao or Lilypad, and sending that data there, and vote on, what to do with the treasury funds, whether that's used to, again, maybe use that to renew storage deals on this data as they're about to expire, access control lists for the data, all kinds of things. Right. And so again, you have the DAO treasury that can fund all these awesome tools that the DAO may find useful. And together this community of corgi owners can get together and pull all the resources to create like a healthier and happier world for corgis, which I think is something everyone can get behind. And so I wanted to talk a little bit, I've mentioned aggregators as a possible path for storing your data. A new, just hot off the press tool that you can use is PodSci, or proof of data inclusion within your data, right? And so right now, Lighthouse.storage is one of the, I believe, one of the only aggregators that is actually using PodSci. And as the name suggests, what the aggregator is doing is they're taking your data and they're combining it with a bunch of other data sets to create one massive data set, right? To make this data kind of viable for storage providers. But all you'll get is that, within those storage deals, all you have is the PCID, or the hash kind of the data, of the full data set, right? And the PCID of your specific data is somewhere within that greater data set, and that's not recorded on chain. So what PodSci does is takes this greater data set and breaks down and creates a like Merkle tree proof of all the sub data sets within this greater data set, and allows you to prove that, hey, my data is within this greater PCID that's stored within on-chain. Right, so I mentioned the Lighthouse aggregator. Here is a link you can find to access it, docs.lighthouse.storage. They have a great walkthrough on how to use it. And I also have some code you can work through in our DataDAO kit, which is right here, which you can find in the Filecoin project GitHub. And this is just kind of a mock kind of skeleton DataDAO for you to work with. It has the client contract already in there. It has a basic front end. And we actually have some scripts for Lighthouse.storage that you can mess around with and upload your data and see the PodSci, right? Right. So here is a link tree to all the FVM resources that you have available. This will have everything listed and more. Hopefully help you along in the hackathon. And yeah, I know we're running up on time here, so thank you. We have a couple of minutes, so if anyone has any questions, feel free to ask them in the chat. And if not, I can use some of the time and give you a very quick demo on PodSci.
Yes, Zach, we did just have one question, which was why do you think people should use Filecoin over perhaps some of the other storage providers?
Yeah, exactly. So I think over the other storage providers, I think Filecoin has some of the best, one of the largest ecosystem of tools. So you see all these like kind of mature tools, and that's kind of one of the themes that have all these presentations that have been built on top of it. Your data is cryptographically kind of guaranteed via these storage deals. And, I'm not 100%, familiar with all the intricacies of other storage providers, but I'm pretty sure that, the Filecoin virtual machine is a very unique selling point to many other blockchains that just are there for just storage and don't allow programmability.
Amazing. Thank you. We've just had a follow-up as well. When will we have a Rust native toolchain for Filecoin? Is there anything you can share on that?
Yeah, there's no hard deadlines. I know that the engineering team is working on that, as we speak. They want to get it right. So, no idea, but that should be one of the next milestones that comes out.
Amazing. Thank you. Well, I'm not sure our next speaker is here yet. So if you did want to go through that demo, please feel free to do so. Otherwise, we can wrap it up now.
Sure. Yeah. I can just show this off real quick. So let me share my different screen real quick. Screen. So this is the DataDAO kit I kind of showed off in the GitHub. It's got the front end, it's got the hard hat. And under scripts, we have a section called Lighthouse SDK. And that has a script called upload file. And this is actually taken from those Lighthouse docs. So basically all it's doing is taking this image I have of my cat and storing it in the using the Lighthouse aggregator to store it within Filecoin and on IPFS. So I've already run this script down here. You'll see node, just run node and run the script. That'll take this file and upload it. It gives you the IPFS hash here. And then once you have that, I'll share my screen one more time. One other tab. Based on these docs here, these Lighthouse docs, you can run a simple GET request to their servers, and you can get that proof of data inclusion, right? So this is it. Like for that exact data I've stored of my cat, that image of my cat, you can get the proof of data inclusion for the greater deal. So it's being stored with all these other bits of data. And so that's kind of the proof of data inclusion. There's a lot more information in their docs about how you can verify the data on chain, like the sub data pieces on chain.
Amazing. Brilliant. Well, Thank you so much. Thank you on behalf of everybody. Extremely insightful. And I think across all the sessions we've had today, everybody should be feeling much more confident with those bounties and just using Filecoin in general. So on behalf of everybody, thank you so much. I don't know if you have any final remarks or any links you'd like to share before we drop off.
Yeah, I just see one question in the chat about a local dev node. You can, if you look up local node on GitHub, on the Filecoin GitHub, you should find a Docker image with a easy to use README that will let you use this. And there is no native WASM actors live yet on Filecoin virtual machine. So thanks for having me.
Brilliant. Thank you so much. And we'll see you soon. Cheers.